Hi everyone, my name is Vaibhav Singh. I work with BMC Discovery Premier Support Team. Let's start with our agenda for today. We will start by understanding Discovery Data Model. Then we will talk about the different consolidation approach that we have available now. We will look at the primary use case for Inferred Model Consolidation. Then we will talk about data flow, that is how the data is sent during Inferred Model Consolidation. We will have a demo where we will see how to configure Inferred Model Consolidation. And considering that now we have two types of consolidation approach available, we will look at all the possible combinations. We will also discuss different sync behavior during Inferred Model Consolidation. We will look at the new command line utility and the APIs that are added for consolidation. And finally, we will talk about the troubleshooting approach. Let's start by understanding Discovery Data Model. In Discovery, we have two types of primary data model. The first one is called as directly discovered data. This is the data that Discovery obtains directly from your target endpoints using a specific discovery technique. You could easily see this information if you go to a discovery access page of a particular node. For example, in this screenshot of a discovery access page, on the left side, you can see the discovery methods, and the right side, the information or the directly discovered information for each of those methods. As you can see that this directly discovered data includes a lot of low level detailed information which you may or may not need from your inventory or asset management point of view. Still, all of the directly discovered data is stored in BMC Discovery Data Store. Based on the directly discovered data, Discovery then creates another type of data model which is called as inferred data, and this is the data that you usually use for your inventory or asset management. The simplest way to see this information is by logging into the Discovery UI and then going to the Explore data page. For example, in this screenshot, you can see the number of servers, network devices, software instances, etc. that are created based on the directly discovered data obtained by Discovery. Now that we have understood the different data model, let's start with our main topic for today, consolidation. Before I go ahead and talk about Inferred Model Consolidation, let me just quickly talk about the consolidation approach that we are all familiar with, and it has been part of the product for many years. Depending upon your network segregation or firewall restriction, you could set up the consolidation like this, where you deploy multiple scanners and configure these scanners to send the data or consolidate the data to one or more consolidator. These scanners will connect to your target endpoints and capture the directly discovered data. Based on the directly discovered data, these scanners are going to create the inferred data, and simultaneously they will send the DDD data to the consolidators, where based on all the DDD data received from all the different scanners, a new set of inferred data will be created. As I said, we are all familiar with this type of consolidation approach since it has been part of the product for many years. But one thing you might have noticed here, that instead of calling scanners just scanner, I'm also calling them DDD sender, and similarly for the consolidator, I'm also calling them DDD receiver. This is because we have a new type of consolidation approach. So let's talk about that. For the Inferred Model Consolidation, the deployment architecture would look similar, but here instead of calling a scanner or DDD sender, I'm calling them as an inferred sender, and for the consolidator, I'm calling that as an inferred receiver. These inferred sender will be configured to sync data to the inferred receiver. When it comes to the discovery, the inferred sender will play the same role. They will connect to the target endpoints, capture the directly discovered data, create their own set of inferred data. But when it comes to syncing the data to the receiver or consolidator, instead of sending the DDD data, they will directly send the inferred data. As a result of that, on the receiver, we will have a consolidated inferred data. Now you might be wondering, what was the requirement behind this new type of consolidation? So let me talk about the primary use case for this new type of consolidation. Keep in mind, this is a primary use case and not the only use case. Depending on your requirement, you could configure Inferred Model Sync differently. For the primary use case, let's say you are an existing Discovery on-prem customer who prefer to keep DDD data or the directly discovered data on premise, and you are looking to utilize BMC Helix AIOps capabilities for service monitoring. The deployment architecture would look something like this. You have your on-premise consolidator setup where multiple scanners are consolidating the data. You might also be doing direct or local scanning from your consolidator appliance. To utilize BMC Helix AIOps capabilities, you could opt for BMC Helix AIOps deployment or SaaS deployment. As you may know, all BMC Helix AIOps SaaS deployments comes with a BMC Helix Discovery SaaS instance, which is commonly known as DSM instance. Now for the service monitoring, you want to use the discovered nodes and relationship information that is sitting on your on-premise consolidator. And considering that you don't want your DDD data to go outside of your premise, in that case, a new type of consolidation was required, and that's where the inferred model consolidation comes into the picture. With this new type of consolidation, now you have the flexibility to only consolidate the inferred data, which is the required information from AIOps point of view. As I said, this is the primary use case and not the only use case. Depending on your requirement, you could configure inferred model consolidation on your on-premise appliances as well. Now let's talk about the data flow to understand how exactly this new type of consolidation works. Let's say we have an inferred sender which is configured to sync inferred data to an inferred receiver. For this new type of consolidation, a new service named Inferred Sync Service has been introduced. On the sender side, this new service will look for any data change event such as create, update, or delete happening in the discovery default partition, which is where the inferred data is stored. And it will sync those changes to the inferred sync service on the receiver side via HTTPS. On the receiver side, the inferred sync service will write that data into a sync partition, which is a new partition created for this feature. And simultaneously, the reasoning service will keep on checking with the inferred sync service about any task that has to be done. Once the data is written to the discovery sync partition, it is now the responsibility of the reasoning service to write that data into the discovery default partition on the receiver side. Now let's take a demo here. We will see how to configure inferred model consolidation, and we'll see what type of data is being sent from the sender to the receiver. I have logged into two discovery appliances. You can see the UI side by side. On the right side, I have renamed the appliance as Discovery Inferred Sender. And on the left side, I have renamed the appliance as Discovery Inferred Receiver. As you can see, I have some data on my sender, but the receiver is completely empty. To configure the consolidation, let's click on the administration icon and then click on Discovery Consolidation. Let's do the same thing on the receiver side as well. As you can see that the consolidation UI has been updated, and to enable the consolidation, we will just click here, and let's do the same thing on the receiver side as well. To configure the consolidation, we will take the DNS name of the receiver, and on the sender side, we will click on this add destination option. Now here we have two options. We can either select to send the directly discovered data, or we can select to send the inferred model. Let's select inferred model, and in the destination URL, we will add the DNS name that we copied from the receiver side. After this, let's just click on add. Now on the sender side, it says that the connection is pending approval, and on the receiver side, I can see the same message pending approval. To approve the connection, I will click on actions and then I will click on approve. So from the receiver side, it is approved right away. But on the sender, it might take 1 or 2 minutes to reflect that. So let's just wait for that. Okay, the connection has now been approved. And here you can see that there is a message saying resync required. We see the same message being prompted on the receiver as well. Please note, when you are creating the connection for the very first time, resync is required. It is required to sync all your data from your sender to the receiver in one go. Even if you don't have any data on the sender, resync would still be required because there are some metadata that has to be synced. To start the resync, let's just click on this actions, and from here we will get the option to start resync. Let's click on it, and you can see that now the resync is running. Depending on data, it will take some time to complete. So let's just wait for that. The resync is now completed. On the sender as well as on the receiver, we can see the count of data that has been created. So let's quickly go to explore data and compare the data on both sides. As you can see that now receiver has received all the data that is there on the sender. Let's quickly have a look at some of the host. So let me click on the number of hosts from the sender side, and let me do the same thing on the receiver. And let's open one of the hosts here to see the details. As you can see, we have exactly the same data. The one difference that you will see when you click on show provenance, let me quickly do that on both ends, that on the sender side, it tells you the discovery method from which the data was inferred. But on the receiver side, it tells you clearly that this data has been sent by this particular sender, so that you know that this data is created as a result of inferred model sync. I will hide the provenance for now, and let's have a look at one of the business service that I have on my sender. So let's go to explore data, again explore data, and let's go inside business services. I will open this one. So on the sender side, you will see that the service type is rules, which is nothing but a service that is created based on a blueprint. If I click on visualize, I can see the visualization. It's a big business service with a lot of nodes. Let me do the same thing on the receiver side. Click on the visualization. Again, I see the same data that I have on the sender. However, on the receiver, I get this option, maintain locally. So let me just quickly talk about that. So right now, the business service is completely controlled by the sender. So whenever the business service is being updated on the sender, that will be updated on the receiver. But let's say you want to maintain this particular business service on the receiver only, and you can do that by clicking on this option, that is maintain locally. And when we do this, as the prompt says, it will stop receiving update from the sender side. Now you can see that now I have the option to edit this model locally on the receiver side. Let's quickly have a look to the other business service. Let's have a look at the first service, which is created using Start Anywhere modeling. And here again, we see the same thing. We have the option to maintain this particular service locally. One more thing you might have noticed, that on the sender, it tells you the type of the service, but on the receiver, it add a prefix sync to tell you that this service has been sent by a sender. Now let's go to manage discovery page, and we will run some scan from our sender, and we will see how that scan is reflecting on the receiver and how the data is coming on the receiver side. I will execute one of the scan from my recent runs. So the scan has started on the sender, and you can see that it quickly appeared on the receiver. Let's just have a look at the progress. So you can see that the real-time progress, whatever is happening on the sender, is also reflecting on the receiver. Okay, the scan has now completed. So let's go to recent runs on both ends and see the result. So here, as you can see, we have exactly the same result what we have on the sender. Let's go inside the host, and let's go inside one of the hosts and see what kind of data was sent by the sender. So obviously we see all the inferred data, but if I scroll down, along with the inferred data on the receiver, I do see the discovery accesses. So let me open the discovery access on the sender as well as on the receiver. And you can see that discovery access as well as discovery run, these two details are sent as part of the inferred model consolidation. These two details, as you know, are part of DDD data, but still they are consolidated in inferred model consolidation, because when you're looking at an inferred node, you might want to know when was the last time it was scanned and what was the discovery run. If from the discovery access page, if I scroll down, I don't see any information about the discovery methods, which is something you can see here on the sender. So we can clearly see only the inferred data with discovery access and discovery run was sent to the receiver and not the other directly discovered data. Let's go back to the host node and I will quickly show one more thing. On the sender side, let me scroll down, and here I see two details that are being populated as a result of a custom pattern. I only have this custom pattern on the sender but not on the receiver. Let me just quickly show you. So I have two custom patterns here on the sender, but those are not there on the receiver. However, if I scroll on the host node on the receiver, I will see those details being populated here as well. This is because if a pattern is maintaining a particular node, in this case I'm populating some packages and their information, then we need the maintaining pattern to be there. And because of that, the sender has sent that pattern on the receiver. But keep in mind, it is just there on the scanner to maintain the node being sent from the sender. It will not have the exact effect what you have when you upload a pattern, because this pattern is not going to trigger when you are scanning something else and the trigger condition is matching. So if you're looking to have the same effect of the custom pattern on the receiver, then it's better that you upload that pattern on the receiver side as well. Now let's go back to the explore data again, and this time I'm going to delete a host from the sender side and we'll see what happens on the receiver side. So let's go inside the number of hosts here. Let's select the first one, action, destroy. So right now we have 9 hosts on the receiver. After refreshing the page on the receiver, we can see that now we have 8 hosts. As we discussed in the data flow slide, whenever we are making any data change on the sender, the sync service will pick that one and it will sync that data to the receiver. And we can see that happening in this case. The moment I deleted the host from the sender, it also got deleted from the receiver. Now let's go back to the presentation and discuss the next topic. Depending on your requirement, you might want to combine these two types of consolidation, that is DDD consolidation and inferred consolidation. So let's quickly understand how you can do that. Let's say you have DDD senders configured to send DDD data to a DDD receiver. You could choose to configure this DDD receiver as an inferred sender, which is going to send inferred data to another appliance which is configured as an inferred receiver. At the same time, you could have another inferred sender sending inferred data to the same inferred receiver. So this is one possibility how you can combine these two types of consolidation approach. There are other available combination which is shown in this particular table. The important point to note, BMC Helix Discovery SaaS instance can only be configured to either send or receive inferred data. Now let's talk about some of the sync behaviors, and the first point is how exactly the nodes are matched up and what happens to the node key. Let's understand this concept via examples. Let's say we have inferred sender and inferred receiver configured. When you created the connection for the very first time, and if let's say the inferred receiver is completely empty, then the node that are there on the inferred sender and their key will be transferred as it is to the inferred receiver. Let's take an example and understand this. Let's say on the inferred sender, we have a host 1 with key 1. Then when this data is sent to the inferred receiver, it will maintain the node key. So on the receiver, we will see the same name as well as the same key. The second possibility is that the node that sender is going to send is already present on the receiver. In that case, on the receiver end, the key will be preserved and it will not change based on the key that is being sent by the sender. This approach will avoid duplication of the root node in case you are scanning the same root node from different inferred senders which are consolidating the data to the same inferred receiver. However, there is one scenario in which you might end up with duplicate if you choose to scan the same set of IP from multiple senders. Please note the recommendation is avoid scanning the same set of IPs from multiple inferred senders which are consolidating data to the same inferred receiver. This is because in BMC discovery, the key is hashed for a few software instances. And if you are scanning and sending those type of software instances from multiple inferred sender to the same inferred receiver, then there is a possibility that those software instances are not matched properly on the receiver end. Please note this is only applicable for a few software instances and it's not going to impact the root nodes such as your host or network devices. But still, if possible, avoid scanning the same set of IPs from multiple inferred senders. Now let's talk about the next sync behavior, that is node lifecycle. Regarding node lifecycle, the first point is on the receiver, if a node is purely created based on the data that it got from the sender, then whenever that node is destroyed on the sender, it will be automatically destroyed on the receiver. This is something we saw during our demo. The next point is if other data sources such as BHOM monitoring or the local discovery on the receiver have contributed to the node on the receiver side, then even if you delete the node on the sender, it won't be deleted on the receiver end. The discovery run and discovery accesses which are synced as part of your inferred sync to the receiver are aged out on the receiver based on the DDD setting that you have configured from your model maintenance page. If for some reason you choose to do model wipe on the sender, then that will not impact the data on the receiver. If you have created manual groups on the sender, then those groups are also synced to the receiver and you can choose to edit them on the receiver without any impact. Let's talk about the next sync behavior, which is resync. Let's quickly understand in what scenario you might need to perform a resync from the sender side. So first scenario is, which is something we saw during the demo, when you are creating the connection for the very first time, the sender will prompt you to run a resync. For an already established connection, there are two possibilities in which you need to run the resync. The first one is, let's say you restore the backup on either the sender or receiver. In that case also you need to run a resync, or the sender tells you specifically to run a resync because it thinks that it is out of the sync with the receiver. Let's talk about the final inferred sync behavior, that is how the inferred sync happen in a clustered environment. If your sender is a clustered, then the data is always sent by the coordinator of that cluster. On the receiver side, you could choose to use one of the cluster machine while creating the connection. But the recommendation is that you should always send the data to the receiver coordinator as well. Because if you send the data to a cluster machine on the receiver, that data will be first forwarded to the coordinator for the distribution. So the recommended approach is when you are configuring the inferred sync consolidation, on the sender side, you add the address of the receiver cluster coordinator. Now let's talk about the new command line interface and the APIs that has been introduced to configure and manage the consolidation. In the screenshot left side, you can see the command line utility named tw_consolidation_control. And on the right side, you see all the newly added REST API endpoint to manage and configure this consolidation. Now let's talk about the logs that you could refer when troubleshooting an issue related to inferred model consolidation. On the sender side, you can review the inferred sync log, which is a new log file introduced for this feature, to see the details of data that sender is sending to the receiver. On the receiver side, In addition to the inferred sync log, you can also review the reasoning logs, because as we saw in the data flow slide, reasoning is the one that writes the data from the sync partition to your default partition on the receiver side. Now let's summarize what we discussed today. We started by understanding the data model within Discovery Data Store. We then talked about the two types of consolidation that we have now. We looked at the primary use case of inferred model consolidation. We took a demo where we saw how to configure inferred model consolidation. We discussed a few sync behavior specific to inferred model consolidation, and we talked about what logs to review to troubleshoot an issue related to inferred model consolidation. For more details on this topic, you can also refer to these references. And with this, I'm going to conclude today's session. Thank you very much for joining.